Okay, Assalamualaikum, salam sejahtera.
Waalaikumsalam, Doktor.
Assalamualaikum.
Semua sihat?
Sihat, Doktor.
Okey. Berapa orang dalam ni? 87. Sepatutnya 90 lebih kan. Okey, habis sign in. Cukup ah. Shirin, Muhaimin, Sasikala, Sharmimi, Aizat, Nur Rakasha, Nur Nabila. Jason Lee, kenapa kau tuliskan? Awak kena reinstall kot awak punya tu, MyUKM tu. Okey. Dah. Jason, tuliskan lagi ke?
Belum lagi, Doktor. Tak, bagi saya 1 minit.
Cepat sikit. Dah.
Sat, Doktor. Sat. Ayo. Okey, Doktor. Done.
Okey. Ya. Okey. 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 So ini minggu kedua kan? Untuk awak. Assalamualaikum dan salam sejahtera. Very good afternoon. So kita continue. But it's still a recap. Sekejap saya pakai earphone lah. Tutup mic sekejap. Okay. Boleh dengarkan? Boleh dengar kan?
Boleh, Doktor.
Okay, alright. So, ini hanyalah recap. So, it's not going to be a long class today. Recap for your soil mechanics. Okay. Alright. Geotechnical properties of soil. Okay, so geotechnical properties of soil such as grain size distribution, plasticity, compressibility, and shear strength can be assessed by laboratory testing. So, awak dah buat extensively your laboratory work in year 2 and year 3, okay, dalam soil mechanics and geotechnics. Okay, in situ determination of strength and deformation properties of soil are considered because this process avoid disturbing samples during field exploration. Sebabnya kalau awak kena bawa sampel tu masuk ke lab, okay, so your soil is already disturbed samples, or at least it will not be completely fresh sample lah. Okay, so ada baiknya there are certain tests that you have to do it in situ, okay, aka dekat situ. Okay, so not all of the needed parameters can be determined because of economic or other reasons. Okay, so katakan awak nak dapatkan certain soil property, so bukan semua tanah awak boleh ambil, ada yang dalam laut, ada atas gunung berapi, ada dekat tepi lereng bukit, so it's not easy to get all the soil samples. Okay, so economic or other reasons. Economic is because kalau awak buat kat tepi lereng bukit, so it must be very expensive to pay people to do it, the soil sampling and yada yada yada. Okay, and focus includes grain size distribution, plasticity, soil classification, hydraulic conductivity, effective stress consolidation, and shear strength parameters. Okay, so awak dah buat semua soil test yang berkaitan ini. You have done all the needed experiments in relation to these properties. Alright. So PSD, particle size distribution. Okay, so katakan awak nak dapatkan size tanah, apakah test yang awak buat dekat dalam lab? Apa soil test yang awak buat dekat lab? Apa nama dia?
Safe analysis.
Safe analysis, bagus. Okay. Alright, hydro what?
Sorry,
Hydrometer.
Hydrometer
Analysis.
Hydrometer analysis. Okay, so safe analysis untuk tanah apa? Hydrometer analysis untuk tanah apa?
Kalau hydrometer fine.
Okay, fine.
Kalau C cost
Okay.
grain.
Okay, very good. Okay, so hydrometer analysis is for finer material, and kalau safe analysis mestilah cost. Okay, cost grain material. Okay, so size of the grains vary greatly in any soil mass. To classify a soil properly, must know its particle size distribution. Okay, so kalau awak nak tahu tanah tu tanah jenis apa, strength dia jenis apa, so first thing first you have to know the size. There's no other way but to either sieve it or run it in hydrometer analysis. Okay, so particle size distribution for coarse grain is determined through sieve analysis. Particle size distribution for fine grain is conducted by hydrometer analysis. So bila awak dah dapat result tu, awak pun combine. Okay, so belah kiri tu adalah sandy material which is your coarse material, and on the right is the silt and clay. Okay, so silt and clay ni adalah fine material. Alright, so kalau awak tengok graf ni, yang bulat-bulat ni semuanya adalah berada di coarse grain. Yang tiga segi ni adalah these triangles are on the right side, which is your hydrometer analysis to indicates finer material. Alright, so what you do is for every percent, okay, percent finer, so 60, 30 and 10, okay, is determined from your to determine the particle size distribution. Okay, so if you have curve like this and curve like that, is all showing the different combinations of soil. Okay, so if you have like very steep like this, okay, it shows that it has a high amount of specific size. Okay, but if you have something very mild, steep curve like this, it shows the the grain size distribution may be evenly distributed. Okay, it means size, you have high here, you have average amount here, average amount here, average amount here, means you have plenty of sizes, okay? But if it's like this, it means you only have, okay, maybe 0.5 and 0.1. But what about the rest of the sizes? So it's not there, all right? Do you get me?
Yes, Doctor.
Okay. All right, so you know this is the sieve analysis conducted by taking a measured amount of dry soil and passing it through a stack of progressively finer sieve with a pen at the bottom. Okay, so bila awak, when you run your sieve analysis, at the bottom must be a pen. If it's not a pen, then everything will go off, and then there's no point. I mean, you still get the grain size in between, okay, but except for the bottom, if you don't use a pen, then you don't have the smaller sizes, okay? The amount of soil retained on each sieve is measured, and the cumulative percentage of soil passing through each is determined and is referred to as percent finer. Right, geotechnical properties of soil, percent finer for each sieve is determined by a sieve analysis and plotted on semi-logarithmic graph paper. So imagine if you don't use logarithmic curves, okay, logarithmic graph pad, okay. So let's say this distribution is very far. So imagine if you use an even scale. So maybe 10 here, 9 here, then here will be the same decimal number. So the curve will be forever long until the end of your, I don't know. Okay, so that's why you have to use logarithmic paper. Notice that grain size diameter D is plotted on logarithmic scale and the perfect finer is plotted on arithmetic scale. Okay, so this is arithmetic, this is logarithmic. Okay. All right, two parameters can be determined from the grain size distribution, which is the uniformity coefficient, which is Cu. So D60 over D10. So you go to 60% and 10%. Okay, so you can get the uniformity coefficient, the coefficient of gradation or coefficient of curvature, Cc equals to D squared 30 over D10 times D60. Okay, so these are all percentages. You know all this already. You've done in your lab work, you've done in your soil mechanics. D10, D30, D60 are the diameters corresponding to percent finer than 10, 30, and 60% respectively. Okay. Hydrometer analysis based on the principle of sedimentation of soil particles in water. So deflocculating agent is added to dry pulverized soil. So you soak for a minimum of 16 hours. Okay. So all of this actually when you run it in the machinery, so they are doing it for you. So at the end of the day, you're just going to get your fine grain size distribution. Okay. So I leave this to you. I'm pretty sure you can read and revise again what you have done before in the hydrometer analysis. Okay, size limits for soils. Okay, several organizations have attempted to develop the size limits for gravel, sand, silt, and clay on the basis of grain size present in soils. Okay, so we use AASHTO or we use USCS. Okay, so AASHTO is Association of State Highway and Transportation Officials. So mostly peoples in the roadway, in the road path will use AASHTO. A unified soil classification system is more for other respective purposes. Okay. All right. When clay, okay, now is ultimate limit. Okay, so ultimate limits, it shows your liquid limit, your plastic limit, your shrinkage limit. Okay, so it shows how your your soil formation. Okay, so when clay soil is mixed with an excessive amount of water, it may flow like semi-liquid. Okay, so if you realize if you have a little bit of water, your soil tend to bind together. Okay, but if it's completely dry, then it is very hard for them to bind. Okay, so if the soil is gradually dry, it will behave like plastic, semi-solid or solid material depending on its moisture content. So LL is the liquid limit, plastic limit is PL, and shrinkage limit is SL. I'm pretty sure you know all this. Okay, so these limits are referred to as ultimate limits. Okay, liquidity index, relative consistency of a cohesive soil in its natural state. So Li equals to W minus PL, LL minus PL, okay, over LL minus PL. W is in situ moisture content of soil. What is the unit for moisture content? What is the unit of moisture content? Anybody?
E.
Huh? E. I'm asking about unit, not symbol. Symbol is W. Water content is W. What is the unit for water content? Percentage. Okay, very good. Okay, so water content, okay, the unit is in percentage. It's not in kilo, it's not in grams, it's not in weight, it's not in other unit, but percentage. Okay, so how much water in specific amount of soil is calculated in percentage for moisture content. Alright, so plasticity chart. Okay, so this actually depends on your group of soil group. Okay, so you have Cl, Ml, Ch, OH, Pi. This Pi determines where you are. Okay, so its plasticity index Pi against liquid limit LL. Alright, so unified system. When classifying a soil, be sure to provide the group name that generally describe the soil along with the group symbol. Okay, so you know how to use the USCS chart before. The flowcharts are used for obtaining the group names for coarse grain, organic fine grain, soil, and respectively. Okay, so if you look here, okay, so if you do your your sieve analysis, okay, so you know how much percent for coarse grain, and then you decide whether it's gravel or sand, whether it's clean gravel and clean sand or sand refined. It all depends on your percentage. Okay, so if it's fine grain soil, you use this one. Okay, so 50% or more passes the number 200. So if it's passes 50%, so it's fine grain. If it's less than 50%, it's coarse grain. And then you have the shapes and clay, okay, whether the liquid limit is less than 50 or more than 50. So which one? So at the end of the day, you get your group symbol and then you'll get your group name, okay? And all the respective procedures can be seen here as well. Okay, so C untuk CU, okay, your coefficient uniformity coefficient is this one, CU, D60 over D10, okay, and then your CC is this one, okay. So all of these are here, okay. And then the group symbols, okay, and group name, okay, depends on the sand and gravel percentage as well, okay. Alright, so unified system, symbols of the unified system, okay, these are the following. I'm pretty sure you understand them. Well graded, poorly graded is about the steepness of the curve just now. Okay, so these are just the combination, the single symbol that can be combined to determine your what group. Okay, like just now you have OH means organic silt and clay and has high plasticity, something like that. Okay, all right. Weight volume relationship. Okay, so you've done this before. Soils are three-phase system consisting of solid, particles, water, and air. The phases can be separated. Based on the separation, the volume relationship can be defined. Okay, so you have your volume and weight, okay, on this left side. Okay, so V is volume, W is weight. So volume equals to what? Volume equals to anyone?
Doktor, apa tadi?
Volume equals to what? V. V equals to?
V equal to E.
V equals to E.
What ratio? Yang tu ke doktor?
No. Saya tanya pasal V, the big V. Okay, this big V equals to what? The answer is there.
OH.
Huh?
V equals to W.
V equals to W. Okay, that's good. Okay, but I want answers in volume. So big V equals to how many V's?
3 V's.
TV.
3V. Okay, sebut balik.
Water. BN. U. Dengan VB.
Hello. V equals to
V air, V water, V solid.
VA, V water, V solid. Okay. W equals to
WA, WW, WS. Sama juga. W is equal to W air, W water, W solid.
YWA equals to 0.
YWA is equal to 0.
Because
But air
it's
tak ada weight.
air.
Air tak ada weight.
Tak ada weight. Betul ke dia tak ada weight? Awak rasa?
Rasanya betul tu doktor. So WA is equal to 0.
Okay, so air, the weight is negligible. Okay, we assume the weight is negligible. So W equals to WA equals to 0. Okay, so that's why for W kita kira WW tambah WS sahaja. What is WW?
Weight water.
What is WS?
Weight solid.
Weight solid. Okay, what is VV?
Volume void.
Okay, what is what? What is volume void? Adila? What is volume void? What is VV?
Volume void is volume air plus volume water.
Okay, volume void is W air plus volume of water. Why volume void is only VA plus VW? Why VV is only VA plus VW?
Okay, sebab volume solid saturated soil. Saturated.
Apa dia? Volume solid of saturated soil. Okay, very good. Any other answer? Okay. Sohail. Sohail. Sohail ke Suhail? Suhail. Where are you? Sivanesan. Siva, where are you?
Ya, doktor.
How many phase do we have?
Doctor, I can't hear properly, doctor. The line is lagging, doctor.
How many phase do we have in soil? Siva. Rizwan,
Ya, doktor.
how many phase do we have in soil?
Three, doctor.
Okay, they are? What are they? What are the phases?
Solid, liquid, and gas, doctor.
Solid, liquid, and gas. Okay, so when you separate them, when you separate solid, can you have void in solid?
Yes, doctor.
Can you have void in solid? You cannot have void in solid. Solid is solid. Okay. You can have void
Void
among
in
the solids.
among
Okay. So you see on the left side, okay, all the blue dots, okay, are solids. Okay. So the gray one, okay, it can be water. Okay, it can be air. Okay. So that's why you have removed the VS, okay, leaving only VW and VA. So that is your void. Okay. So solid is solid. Okay. So void among the solids is your VV. Okay. So VA and VW. Right. Based on this separation, the volume relationship can be defined. All right. So void ratio equals to E, which is VV over VS. Okay. So if you look back, VV over VS is your void ratio. But what about its porosity? It's VV over V. V is the big V. Okay. So VV over the total V is porosity. VV over VS is the void ratio. Okay. What about degrees of saturation now? So VW over VV times 100. Okay. So V water over volume void times 100% is your saturation. If you want to know how saturated the soil is, okay, so you calculate the volume of water. Okay. All right. Moisture content, you know about this. Weight of water over weight of solid times 100%. Okay. So it's in percentage. Moist unit weight, okay, gamma equals to W over V. Okay. So this is the big V, the big W. Okay. Dry unit weight is WS over V. So you remove the water content, leaving WS. Okay. So total weight of the soil specimen equals to W equals to WS plus WW. Okay, total weight of the soil specimen. Okay, so W, okay, big W is just WW plus WS. There's no WA because WA equals to 0. All right. Specific gravity is defined as the ratio of the unit weight of a given material to the unit weight of water. Okay, so GS equals to rho S over rho of water. Okay, so it's a ratio of a given material, okay, which is your solid, okay, over weight of water. So P rho S is depending on any type of material. Okay, so different material, different soil will have different specific gravity because you have different solid solid density. Okay, the specific gravity of soil solid can be determined accurately through laboratory tests, definitely. Okay, so like I said, as you can see, okay, so weight volume relationship. So you know all this, you can actually derive from the this main equation just now, like VV equals to VA over VW, W equals to WW plus WS. Okay, so all of this you can derive and form other equations. Okay, so such as WS equals to GS times gamma water. Okay, so WW is what? Okay, so WW means you have GS gamma water times water content. Okay, so 1 plus water content, you can actually simplify this. Okay, this is for dry unit weight, this is for saturated unit weight. Okay, so you've done this before, this is just recap, you can read this on your own. Okay, so various form of relationship, okay, you are well aware of this. Okay, so you use this before. Okay, it's just a matter of different derivations. Okay, so it is depend on what properties that you have. Okay, so let's say you want to calculate dry unit weight with water content. This is the equation. You want to calculate dry unit weight with specific gravity with void ratio. So this is the equation. If you want to calculate with saturation, this is the equation. Okay, all right. It's the same for all this. Okay. Soil compaction, relative density. For granular soil, the degree of compaction in the field can be measured according to relative density. Okay, so E max is void ratio of the soil in the loosest state. Okay, so max means the void ratio is at the highest state. Okay, means the loosest state means it's very, very loose. Okay, so that is Emax, and Emin is when it's the densest. Okay, so when you have different void ratio, okay, so the Emax minus E, okay, and Emax minus Emin times 100. Okay, okay, E is in situ void ratio. Okay, all right. So relative relative density. Okay, the equation is E max minus E min equals to 0.23 plus 0.06 over D50 mm. So D50 is at percent final for 50%. Okay, and then you find the at what size. Okay. Alright, so these are the example of geotechnical interpretive reports. Okay, so you have ultimate limit, specific gravity, densities, particle size distributions. Okay, so these are all given in depth. Okay, so let's say zero is your ground surface. Okay, so as you go down, okay, kalau awak masuk dalam tanah tu 1 meter ke dalam, 2 meter ke dalam, 3 meter ke dalam, as you go down deeper in soil, okay, 1 meter depth, 2 meter depth, 3 meter depth. So these are the ranges that you have. So ultimate limit, okay. So PL, LL, GWC, and then bulk density, dry density. What is this? Clay, seal, okay. Particle size distribution. So how much percent of clay, how much percent of seal, okay. So these are the densities, okay. Okay, so hydraulic conductivity. Hydraulic conductivity is about water flowing through your soil. You've done this before, okay, awak dah buat lab, okay, and then you understand permeability. So permeability is in relation to hydraulic conductivity. Water flows between void spaces or pores between soil grains. Knowing how much water is flowing through soil per unit of time is important for soil mechanics and foundation engineering. Okay, so imagine if you do seepage analysis, you have to know how much water is passing through the soil. So it must be a rate. Okay, so how much water over time. Okay, water flow knowledge is required for designing earth dams, determining seepage under hydraulic structures, and dewatering foundations before and during constructions. Okay, the equation is V equals to KI. Okay, so it's used to calculate the velocity of water, flow of water through soil. Okay, so I is the hydraulic gradient. Okay, so you cannot have water flowing without gradient. Okay, if the gradient is all the same, okay, there's no hydraulic gradient, you cannot have water flow. Okay, imagine kalau awak ada satu bekas, if you have one container, okay, and there is no difference in the hydraulic gradient, there is no difference in the height or whatsoever, so there's no flow. But when you lifted the container, maybe slightly one side, a little bit up, okay, a little bit higher, then you will start see the water moving. It is because you have the hydraulic gradient. So hydraulic conductivity is the is the coefficient, okay, and density velocity is the rate of hydraulic conductivity. Hydraulic conductivity is defined as I equals to delta H over L. So as you have the changes in the height, okay, the changes in the head between two sections, then only you have water flow. Okay, all right. So I is delta H over L. L is the distance between the two clay, and you have coarse grain. Okay, so as you can see, in between coarse and clay, and in between coarse and finer, which one will allow water to pass more and faster?
What was the question again, Doctor?
In between coarse and finer material of soil, which one will allow water to pass faster and easier?
Course.
Course.
Okay, so imagine if you by the beach, okay, if you pour some water, you can see that the water easily seep into it, okay, and goes way deep under the ground, okay. But if you pour water on clay material, okay, let's say after the rain on football field, okay, sometimes you see a pool of water, okay, in between the grass, okay, awak boleh nampak air bertakung because the soil is very is either peat or clay material, okay. So it doesn't allow water to pass through easily, okay. So that's why you have that pool of water, okay. So every soil particles will have different type of hydraulic conductivity, okay. So steady state seepage, for most cases of seepage under hydraulic structures, the flow path changes direction and is not uniform over the entire area, okay. So bila awak dah ada a difference in hydraulic gradient, okay, so the water will follow where the lower gradient is, where it's leading to, okay. So imagine awak tumpahkan air, okay, dia akan bergerak mengikut dia punya the hydraulic gradient, okay. Sorry, sekejap, okay. Alright, so for most cases of seepage under hydraulic structures, the flow path changes direction and it's not uniform over the entire area. Okay, it depends. It's not uniform. One of the ways for determining the rate of seepage is by graphic construction referred to as flow net. Okay, so we've done flow net before. How you draw the flow net? Okay, so if you remember in flow net, what is the most important thing? Awak ingat tak flow net tu yang mana? Still remember this?
Tak ingat, Doktor.
Tak ingat. Tak ingat. Awak dulu soal dengan saya online ke kelas?
Kelas, Doktor.
Kelas. Kalau kelas saya, I'm pretty sure I actually taught you how to draw on the blackboard so many times, on the whiteboard. Kalau saya bagi quiz sekarang, so should I give 0 to everybody?
Ya, Doktor, ada aja.
Okay, so what is the most important thing in drawing flow net? Apa benda kalau awak ingat apa yang saya cakap? How to determine the flow in flow net? Tak ada seorang pun ingat?
Flow line.
Flow line. How do you make the flow line? How do you make the equipotential line?
90 degree.
Apa dia? Ulang balik.
Degree from flow line. Equipotential.
Jawapan lain. How do you draw? Okay, awak nampak flow line pada B to C tu. Okay. So how do you draw the line? What determines the line? Awak nak bengkok macam mana? Awak nak sengit macam mana? Awak nak panjang macam mana? Awak nak rendah tinggi macam mana? How high and how low to draw the lines? Sarah Fitri? Syaimah? Tak ingat macam mana nak lukis flow net? Mirul Ashraf? Tak ada?
Doktor, the flow element form a approximate square.
Approximate square. Okay. So, square tu macam mana nak jadikan dia square? Dalam square tu kena ada apa? Tak ingat. Okay, so awak carilah jawapan tu. Nanti saya tanya in the next class. Alright, so steady state seepage. Okay, so you have Kx, Ky and Kz is the hydraulic conductivity of soil the X, Y and Z direction. Okay, so awak ada paksi X, paksi Y and paksi Z. Okay, so it goes into three-dimensional flow. Okay, so from the apa namanya, the hydraulic conductivity, you have flow in these three directions. Okay, so flow net is a combination of numerous equipotential lines and flow lines. A flow line is a path that water particles will flow travelling from upstream to downstream. That is very common. Okay, air akan turun daripada atas ke bawah. An equipotential line is a line along which water in piezometers would rise to the same elevation. Okay, but how to draw the equipotential line and how to draw the flow line? Okay, your friend said you draw as in regards to squares, but how do you make sure they are squares? Okay, so nanti saya tunggu jawapan dalam next class. Effective stress. Okay, so the total stress at a given point in soil mass can be expressed as sigma equals to sigma prime plus U. So sigma is total stress, sigma prime is effective stress, and U is pore water pressure. Okay, so untuk dapatkan effective stress, okay, untuk dapatkan ni effective stress, okay, what you do is you get the total stress minus the pore water pressure. Okay, so nak dapatkan tanah yang ada effective stress, you just tolak dia punya air. You just remove the water, the pore water pressure. Okay, so you get the effective stress. Steady state seepage. The effective stress sigma prime is the vertical component of forces at solid to solid contact points over a unit cross sectional area. Okay, so steady state seepage. Okay, is the effective stress prime vertical component of forces from solid to solid contact points of a unit cross-sectional area. Okay, so unit weight, groundwater level, saturated unit weight. Okay, so what you do is you look into the cross-sectional area F1 and F2 and this apa namanya, length. Okay, so from here you can get the cross-sectional area and then you can get the steady state seepage. Alright, steady state seepage in reference to point A to the figure, effective stress is calculated by the equation sigma prime gamma times H1 plus gamma prime H2. Alright, so this is H1, this is H2. So if you times gamma H1 and gamma set H2, okay, okay, you plus them together, so you can get the apa namanya, steady state seepage. Okay, consolidation happens when you apply load for a certain time. Okay, and then it allows for apa namanya, the stress to stabilize. When stress on saturated clay layer is increased, for example by the construction of a foundation, the pore water pressure in the clay will increase. Okay, alright, so bila awak ada stress, okay, dekat atas tanah yang saturated, okay, so what happens is the pore water pressure, okay, will increase. The hydraulic conductivity of clay is very small and sometimes will be required for excess pore water pressure to dissipate and for the increase in stress to be transferred to soil skeleton. Okay, so what happens is when you have pore water pressure in the confined area, okay, and then you still apply load, so it has to find a way to go somewhere. Okay, what happens is it's transferred to the soil skeleton. It goes into the soil skeleton. Okay, all right. Consolidation. So I think we you know this. You have done this before. So effective pressure against void ratio. Okay, so slope CC is the stiffness of swelling in compression index. Okay, CS is the swelling index. Okay, and C prime sigma prime C is the pre-consolidation pressure. Okay, alright, I don't have to go through this. Shear strength is S equals to C prime plus sigma prime tangent phi prime. Okay, instead of S you can also write what here? Anyone knows? This is shear strength. Okay, what can be represented here selain pada S? Awak dah belajar dah dulu, but I'm pretty sure you can remember nothing. What do you think? S? Okay, I leave this to you as well. Okay, sebab if you cannot recall this, we cannot carry on for your advanced calculation later in foundation. Okay. Tau. Very good. Okay. So you have tau. Okay. Tau bentuk dia macam tu, macam tu. Okay. So shear strength of soil is defined in terms of effective stress. Okay. So tau equals to C prime plus sigma prime tangent phi prime. What is C prime is the cohesion. What is the sigma prime is your effective normal stress. Okay. And phi prime is the effective stress angle of friction. Okay. Very good. Okay, so shear strength, macam mana nak kira shear strength? Awak dah buat lab test, awak buat direct shear test. Okay, so direct shear test means awak kapitkan dua blok tanah and awak lalukan dia berdua. Awak shear strength, awak shearkan dia. Okay, so you calculate how far it can go, and that is your shear test. And then direct shear test is when you have a soil wrapped in a membrane in water, right? And then you see the changes when you allow water to drain on or you apply load. Okay, so direct shear test. Okay, like I said, okay, like this one go to left, this one go to right, and then you push that. Okay, what you get is the effective normal stress against shear stress. Okay, dry sand can be tested by direct shear test. Okay, the sand is placed in a shear box that is split into two halves. First, a normal load is applied to the specimen, and then a shear force is applied to the top half of the shear box to cause failure in the sand. Okay. Direct shear test is something like this. Okay, you've seen this before. Awak dah pernah masuk lab, awak pernah tengok all this soil in membrane. Okay, and then they allow stress to develop because of the confining water. Okay. Alright, so traction test can come in three types: consolidation drain, consolidation undrained, unconsolidated undrained. Okay, so drain means you take the water out, undrained you don't take the water out, and unconsolidated undrained you don't consolidate and you don't take the water out. Okay. Alright, so traction test, sigma prime 1 equals to sigma prime 3 tangent square. Okay, 45 plus phi prime over 2 plus 2c prime tangent 45 plus phi prime over 2. Okay, so 45 plus phi prime over 2 is the same. So this is actually your saya dah lupa dah apa benda ni. Apa benda tah? Saya tak ingat. Okay, so but the most important thing is phi sigma, okay, is the loading, okay, phi is the soil angle of friction, and c is your cohesion. Okay, so as you can see, sigma 1 goes to sigma 3 prime, sigma 1 goes to sigma 3 prime. Okay, so this is c, which is your cohesion. Okay, pintasan y dekat sini. Okay, so this is a clay material. If it goes here, okay, so it's sandy material. C equals to 0. Okay, and then this phi, which is your angle of friction, and this is your shear stress kali dengan considered drain test. Alright, considered undrained test. And okay, that's all for recapping what you've learned in soil mechanics. Okay, alright, so I know it's actually quite a fast topic, okay, but it's actually you've learned this before. So what I'm trying to tell you that you have to, if you feel that you cannot follow, it means that you have forgotten what you've learned in soil mechanics and geotechnics. So kindly revise before we move on to your advanced calculations in foundation. Okay, because after this, okay, kita akan mula masuk ke subsoil exploration is still theory. Shallow foundation is a lot of calculation. Vertical stress increase as well. Okay, settlement, pile foundation is the toughest, pile 1 and pile 2. lateral earth pressure, retaining wall, embedded wall, soil improvement. Okay, and then you have a group project. Okay, so shallow vertical stress settlement is very tough. So ingat balik awak punya shear strength. Okay, awak ingat balik awak punya tau, awak punya phi, awak punya C, awak punya angle of friction, awak punya unit weight. Okay, right? Okay, so any question? Any question? Tak ada?
So far tak ada, Doktor.
Okay, alright. So semua okay Alhamdulillah. Okay, so sekejap. Saya rasa kalau buat quiz yang ni macam boring. Okay, so tunggu habis subsoil exploration, then we will have your first quiz. Okay, so kita akan combine chapter 1, chapter 2, chapter 3, intro, geotechnical properties and subsoil exploration SI, then we do your first quiz. MCQ in UKM folio will be very easy. Awak boleh tembak pun boleh dapat markah, ataupun boleh tembak dan salah tak dapat markah. Okay, so tapi quiz tak banyak mana pun. Quiz is only 2.5% of your total marks. Okay, any question? Tak ada?
So next week chapter 3 tak apa quiz.
Chapter 3 tak ada quiz. Okay, macam ni. Next week kita buat kelas hari Isnin sebabnya awak cuti hari Khamis kan?
Cuti Deepavali.
Okay, so hari Isnin tu kita buat kelas lah sebabnya subsoil exploration is not that long. It's very short. Okay, so kelas sejam Pukul apa? Pukul 4.5 juga kan? Tapi saya rasa macam saya ada bengkel lah.
Doktor pukul 4.5.
4.5. Sekejap Isnin Monday. Okay, tak apa, bengkel saya 2.30 sampai 4.30. So pukul 5 kita boleh masuk kelas. Okay, so next week kelas Isnin
Okay, Doktor.
Alright, so kalau dah tak ada apa-apa, we end our class here. Alright?
Doctor?
Okay, Doktor.
What about the slide?
Which one? The second one.
What?
This is the second. Oh, I haven't uploaded the first one, is it? Belum
Yes. Belum.
Okay, nanti saya upload sekejap lagi. Kalau tak sekejap lagi esok. Besok saya nak cuti. Sekejap lagi lah saya upload. Okay, alright. Okay, semua? Alamin, I will upload the notes later. Okay?
Okay.
Thank you, Doktor.
Alright.
Thank you, Doctor. Thank you, Doctor.
Thank you, Doktor.
Thank you, Doktor. Thank you, Doktor. Stop.